Hi everyone. Sorry that I am not there today, but this is what I have for y'all today. So this is what we went over a few days ago, but we never went over this specific problem. We mainly focused on free body diagrams on Friday, but we didn't really focus on many calculations. But let's first go over this problem with a free body diagram. So a 400 kilogram hippopotamus is pushed with a 200 Newton force, but the rusty cart wheels produce a 50 Newton frictional force. Okay. What net force is exerted on the hippopotamus, and what acceleration will the hippopotamus experience? So whenever it asks for net force, we want to consider both the x and y directions. So the x direction, left and right, and the y direction, up and down. Okay, so free body diagrams can really go both ways, and using this dot to symbolize the center of mass between the dude and the hippopotamus, we're going to draw a force of gravity that goes down for the center of mass between them two. And because it's on a surface, there's an equal and opposite force normal going up. And we know that it is equal and opposite because it is not accelerating in the y direction. The net force between the two forces are going to be equal to 0. So we already know that because the net force in the y direction is going to be equal to 0, because acceleration is equal to 0. Okay, because this object is at rest in the y direction. So it's only moving left and right. Okay, in y direction. And we'll see how calculations will prove that as well. But let's look at the net force in the x direction. So in the x direction, we see that this dude pushes the hippopotamus with a applied force of 200 newtons. So force applied will equal 200 newtons. And also there is a force of friction, which is way smaller, and it's going to be a force of friction, and it's going to be equal to 50 newtons. So we're going to consider the positive direction as going to the right. So if the positive direction is to the right, then 200 is going to be positive, while 50 is going to be negative. So 200 minus 50, the net force is going to be 150 newtons to the right, or in the positive direction, whatever. So that answers that. And we also know that because there is a net force in the positive direction or the right direction, that means there will be an acceleration, which is what B asked you for. So because there is an acceleration, we can use our F net equals ma equation in the x direction. So F net in the x direction to find what the acceleration is. So we're going to plug in 150 for F net, and then I'm going to plug in 400 kilograms for the mass, and then whenever I want to solve for acceleration, I divide by 400 on both sides. And then whenever I do that, my acceleration should be 0.375 meters per second squared. Okay. So this dude is pushing this hippopotamus in the right direction, and he is accelerating at a constant acceleration of 0.375 meters per second squared. So let's go backtrack a little bit and talk about the net force in the y direction. So we already know that it's going to be 0, but why is it 0? So if I were to look at the the mass that is given for the hippopotamus, I can plug this into an equation. I'm going to come down here. F of g is equal to mg. So we learned on Friday that F of g, and in your notes, your video notes, that the weight is equal to F of g, which equals mg, which is just a modified F equals ma equation, Newton's second law. But we want to find the force of gravity due to the weight of the hippopotamus. So as stated before, the weight of the mass of the hippopotamus is 400 kilograms. I am going to use, so usually gravity is 9.81 meters per second squared, but I'm going to cheat a little bit and I'm just going to use 10, so I'm going to round it up. So usually during lab I'll ask you to use 9.81 to be more precise, but I'm just cheating so the video can be a little bit shorter. So the force of gravity due to the hippopotamus is going to be 4,000 newtons. So since it's 4,000 newtons, I'm going to plug it in over here, 4,000 newtons. And I also know that because the hippopotamus dude system is going to push on the ground with 4,000 newtons, the ground is going to push back up against it with 4,000 newtons as well. My bad, I wrote kilograms. So that is how you solve also F net in the y direction, because 4,000 minus 4,000 is equal to 0. So I'll just write it down over here. Ta-da!